Today we are going to discuss some other topics in Unit 2, that is diagrams. So representing the relations using the diagrams. Diagrams is an important topic. So diagraph means it consists of edges and vertices. So the definition is a directed graph. Directed graph means it has directions. That means it has arrows, or digraph consists of set of V vertices. V is called as vertices, or simply we can call it like nodes, together with a set of edges. That means E means edges, or simply we can call it as arcs. So with the ordered pairs of elements of V called as edges or arcs. So a directed graph which consists of a set of vertices and edges is called as a digraph. The vertex A is called as internal vertex of a edge AB, and the vertex B is called as terminal vertex of the edge. So we can use arrows to display the graphs also. So here this is about the digraph. So digraph means a directed graph. A directed graph in the sense it has directions. That means it has arrows. So this is the diagram. Representing the relations using the diagram. Here he has given an example. He has asked to display the diagram with what is as V equal to, he has given V equal to ABC. That means he has given 4 elements, and E equal to AB, and he has given the values AB, AD, BB, BD, CA, CB and B. If he will give some vertices and he will ask one condition also, by the condition we can draw the diagram. So similarly here we are having 4 variables, that is ABCD. So we can plot ABCD wherever we want. See here I am plotting ABCD, or simply I can draw a line also. By help of a line also we can draw the diagram. So anything we can draw. We can draw with simply a straight line also we can draw, or simply like this also we can draw. So here I am taking ABCD, A, B, C, D. So now first of all I have to point A, B, C, D. These are nodes. I am pointing the nodes or vertices. See here, first AB, A to B. I am drawing a line A to B, arrow, directed line. Next A to D, A to D. Next B to B. B to B is called as a self loop. It is called as a self loop. Next B to D. Here B to D, B to D. Next C to A, C to A. Next C to B, C to B. Next D to B, here D to B. So now this becomes a diagram. So diagram can be written like this also, or simply by the help of a line also we can draw a diagram. Only that we have to point the values and we have to simply write the directions. Here directions are very important. So this is about the diagram. An edge of a form BB is called as a loop. Here it is BB means it is called as a loop. So this is about the diagrams. Now poset. This is very important definition, and it is used and it is given many times in the examination. Now poset means it is also called as partial ordered set, or poset or ordered set. The definition is partial order is denoted by the symbol less than or equal to. Here it is denoted by the symbol less than or equal to. If less than or equal to is a partial ordering P, then the order pair P less than or equal to is called as partial order set, or simply a poset. So simply a poset means here the symbol is less than or equal. Poset means we already know that poset means it is rat, RAT rat. Rat in the sense R means reflexive, A means antisymmetric and T means transitive. So poset means it must satisfy the reflexive property, antisymmetric property and transitive property. So here partial order is always denoted by the symbol less than or equal to. So if less than or equal to is a partial ordering, then the order pair P less than or equal to is called as a partial ordered set. So here it is rat. Rat means reflexive, antisymmetric and transitive properties. It must satisfy these properties. Now Hasse diagram. This is a long answer question. It is very important and it is easy to draw. The Hasse diagram means the graphical representation of a partial order relation in which all arrowheads are understood to be pointing upwards is called as Hasse diagram or poset diagram. Here we can take off, here we are having some rules to draw the Hasse diagram by taking down the arrows. by removing the reflexive property, by removing the transitive property, by removing the arrows, by removing these we get a Hasse diagram. So now we see the some of the conditions to draw a Hasse diagram. So procedure to draw a Hasse diagram. First of all, construct the digraph for the given partial ordering relation. We have to construct the digraph. Since the relation is reflexive, we already know that poset means it is a rat. Rat means it is reflexive. Reflexive, antisymmetric and transitive. Since the relation is reflexive, then eliminate the self loops. So we have to eliminate the self loops. Since the relation is transitive, so we have to eliminate the transitive edges also. Why? Because it is a poset. Poset means RAT rat. Rat means reflexive, antisymmetric and transitive property. Next, eliminate the arrowheads. We have to eliminate the arrowheads. So these are the procedure to draw the Hasse diagram. So the procedure is we already know that poset means it is having the three conditions RAT rat, in the sense R means reflexive, antisymmetric and transitive. First of all, here we have to construct the digraph for the given partial ordering relation, and in the next case we have the relation is reflexive. We know that it is reflexive, so we have to eliminate the self loops, and since it is a transitive property, since it satisfies the transitive, we have to eliminate the transitive edges, and at last we have to eliminate the arrowheads also. Then we get the Hasse diagram. Now we see in a problem. See here he has given a problem. Let x equal to 2, 3, 6, 12, 24, 36 and less than or equal to. Already we know that less than or equal to means it is a poset. Be a relation such that x is related to y, x divides y. Draw the Hasse diagram of x less than or equal to. So the diagram simply it looks like this. See, we see whether how it works. See, first I have taken given x equal to 2, 3, 6, 12, 24 and 36. First of all, I have taken the values. Next he has given that condition is less than or equal to. It is less than or equal to. Here is given x divides y. X divides y. That means remainder we have to get 0. So first of all I have written that given x equal to 2, 3, 6, 12, 24, 36. Now he has given that x divides y and x less than or equal to. Condition is x less than or equal to and x divides y. Suppose if I have taken 2, then 2 must divide the some values. If I have taken 3, then 3 must divide some values. If I have taken 6, then 6 must divide some values. Similarly 12, 24 and 36. So first of all we have to write the relation R based on the condition x divides y and less than or equal to. We have to put in the mind that it is less than or equal to also. So R equal to, first I am taking 2. So 2, here the condition is x divides y. Divides means remainder must be 2, and less than or equal also it is there, less than or equal also. So we get the values 2 comma 2, 2 2, remainder 0. 2 3, no it will not come, remainder will not come, become 0. 2 6, yes 2 6, and 2 12, yes 2 12, we get remainder 0. 2 24, yes we get remainder 0. 2 36, we get remainder 0. So x divides y means first of all I am taking 2 and seeing whether I am checking whether x divides y or not, and less than or equal also is there, so I am taking 2 2 also. So x divides y, that means 2 divides 2, 2 divides 6, 2 divides 12, 2 divides 24 and 2 divides 36. Similarly now I see 3. So 3 divides 3. 3 divides 3 and less than or equal also here saying 3 divides 3, 3 divides 6, 3 divides 12, 3 divides 24 and 3 divides 36. That means we get the remainder of 0. Next similarly next value is 6. That means 6 divides 6. We get remainder 0. 6 divides 12, 6 divides 24 and 6 divides 36. Next 12. That means 12 divides 12. 12 divides 24. 12 2s are 24. 12 divides 36. 12 3s are 36. So 12 divides 12. 12 divides 24 and 12 divides 36. Next 24. 24 is divided by 24. We get the remainder 0. Next that is only one case. If we take 24 36, we will not get the remainder of 0. Now 36 is also having only one case, that is 36 comma 36. Our condition is less than or equal to and x divides y. So these are the conditions. So these are the values of the relation. So first of all we have to see that first condition of a Hasse diagram is we have to remove all the self loops. That means we have to remove the reflexive. Here we are having a reflexive means 2 2. We have to remove 2 2. We have to remove 3 3. We have to remove 6 6. We have to remove 12 12. We have to remove 24 24. We have to remove 36 36. So why? Because since it is reflexive. Reflexive means removing all the loops. Reflexive means we already know x is related to x, 2 is related to 2, 3 is related to 3, x is 6 is related to 6, 12 is related to 12, 24 is related to 24, 36 is related to 36. So the first condition is reflexive. So we have to remove all the loops. Next, remove the transitivity. Next, we have to remove all the transitivity. Why? Because it is a poset. Poset means reflexive, antisymmetric, and transitive. That is RAT. So we have to remove all the transitivity. We have to check each and every element, and we have to remove the transitivity. Remove all the arrows. Then we get the Hasse diagram. So we get the Hasse diagram like this. This is the Hasse diagram. Here, by doing that conditions, I have a Hasse diagram. 2, 3, 2 divides 6, 3 divides 6, 6 divides 12, 12 divides 24, and 12 divides 36. At last I will get this Hasse diagram. So this is the Hasse diagram for the given problem. So like this only we cannot draw the Hasse diagram. Simply we can draw by using a line also. By taking a line also we can draw a Hasse diagram. So we have to put in a mind that the poset, we have to satisfy the RAT, that is reflexive, antisymmetric, and transitive property, and we have to check the three conditions. Number one is reflexive, so we have to remove the reflexivity, we have to remove the transitivity, we have to remove all the arrows. Then we get the Hasse diagram as follows, and we have to check the condition also. X divides y and it is less than or equal to. So here I am having 2. First I am taking 2. 2 divides 6 and 3 divides 6. 6 divides 12, 12 divides 24, and 12 divides 36. At last I will get the Hasse diagram as follows. This is a very important problem. He has given many times in the examination also. Next I am taking another example. Given x equal to 2, 3, 6, 12, 24, 36. X divides, I have already done this. This is the another problem. Let a equal to 2, 4, 8, 16, 32. He has given the values, and less than or equal to be the relation. Already less than or equal to means poset means less than or equal to, and divisibility, and draw the Hasse diagram he has asked, and he has given the values. So the Hasse diagram is this. First of all 2, 4, 8, 16, 32. We have to follow the 4 conditions. That is, number 1 is we have to check the poset, that means RAT, that means reflexive, antisymmetric, and transitive. First of all we have to remove the reflexive. Why? Because it is a poset. Next transitivity. Next we have to remove the self loops. Any self loops are there, we have to remove, and we have to remove the arrows also. At last we get the Hasse diagram as follows. This is the Hasse diagram for the given problem. So simple diagram, I am taking a simple diagram. Let A be a set of divisors of 32 ordered by divisibility. That means A equal to 1, 2, 4, 8, 16, 32. Now by following the rules of a Hasse diagram, I have a Hasse diagram as 1, 2, 4, 8, 16, 32. By removing all the reflexivity, by removing all the self loops, by removing the transitivity, and by removing the arrows, I get an Hasse diagram like this. So this is about the Hasse diagram. So this is about the Hasse diagram. It is very easy to understand and it is very easy to draw. The main conditions we have to put in mind that in drawing a Hasse diagram, number one, first we have to see that reflexive property. That means we must not have the self loops. That means 2 2 3 3 4 4 like that. And the next condition is transitivity. We have to check the transitivity.